Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Facade Design with Light Gauge Steel Frames. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to elders past, present, and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, BlueScope. BlueScope is a provider of innovative steel materials, products, systems, and technologies, headquartered in Australia with operations spread across North America, New Zealand, Pacific Islands, and throughout Asia. BlueScope is one of the world's leading manufacturers of painted and coated steel products. And with strong expertise in steel, they provide vital components for houses, buildings, structures, and more. With more than 160 operations and sales offices across 18 countries, they employ over 14,000 people and serve thousands of customers every day, including engineers, architects, and specifiers. BlueScope's strong partnerships and networks are built on their recognised product brands such as Colorbond Steel, Zincalume Steel, Galvaspan Steel, and TrueCore Steel. Today, we will hear from two speakers collectively, followed by a live audience Q&A, and I encourage you to send questions through to our speakers by the chat box. And I'd like to introduce our first speaker, Felix Dong. Felix is a principal of LD Consulting Engineers based in Melbourne. With a career spanning over 10 years, Felix has extensive experience in the commercial construction industry. In recent years, Felix has been engaged in major Melbourne-based infrastructure projects, including the Level Crossing Removal Initiative and the Underground Train and Road Tunnel Project. Please welcome Felix Dong. I'd now like to welcome our second speaker, Luke Cockrell. Luke is the Managing Director of CMG Frames, a leading light gauge steel design and fabrication company based in Melbourne. Luke is a construction professional with 20 years of experience ranging from on-site installation, project management for Tier 1 construction projects, and for the past 8 years has been the driver of LGS Steel Design Solutions on many major Victorian building projects. Please welcome Luke Cockrell.
Thanks for the introduction. So today we'll be discussing some of our major facade projects across the transport infrastructure sector, the impressive lightweight bricked face features we are seeing as an emerging architectural trend, and a range of other general construction projects that CMG Frames is specialising in. We'll be talking about how we are able to save time and money by drastically reducing the overall steel tonnage for our clients, while at the same time simplifying a typically complex step in facade construction. CMG Frames have been designing and constructing TrueCore lightweight steel frame facades for over 6 years and continue to develop our designs by closely working with our key industry partners. CMG Frames work exclusively with LD Consulting to develop our unique facade solutions for the construction industry, and today you will hear how we bring the sometimes seemingly impossible on paper to a constructed reality. The transport infrastructure projects we will be discussing are a part of the Level Crossing Removal Project scheme that the Victorian Government has committed to removing 110 dangerous and congested level crossings across Melbourne by 2030. These projects involve predominantly taking current railroad crossing to an overpass while incorporating a new station. The new station and overpasses are filled with architectural features and impressive design. These features are designed to improve the appearance of a new raised platform whilst maintaining an aesthetically pleasing appearance. The architectural direction and the time constraints imposed on these projects mean there is a major scope for lightweight steel facade structures. Curran Station was one of the first level crossing removal projects CMG Frames were involved in. working with our long-term carpentry and cladding clients, Casello, we were asked to provide an alternative solution to the currently designed hot-rolled steel structure drawn in by the architects. The major benefits CMG frames were able to bring to the project was a short lead time of fabrication of lightweight steel, an easier installation method, as cladding can be fixed directly to our TrueCore frames without the need for secondary battens and straightening, and far less impact on an already crowded site, resulting in a huge cost saving. TrueCore were able to assess and certify the design by providing a design life statement for the lightweight steel, which was a huge tick for the consortium building the project, as there was nothing like it able to be offered by the hot-rolled steel fabricators under the previous design. Our scope was to provide a shape structure to support the CFC cladding while concealing the services from the above platform for a kilometre to the underside of the overpass. The end result was to resemble the existing structural concrete beams in shape and finish, creating an architectural representation of concrete when in fact was a lightweight steel structure concealing station services. CMG frames designed a modular system in suitable sizes to be handled manually to eliminate the need for any cranes and allow the light gauge steel structure to be installed using scissor lifts and booms. You can get a bit of appreciation for the sequencing here. These pictures show the small first access point from one supporting column to another, while the installation of the services were continued down the remaining overpass. A bit about our process and how we work. We take the original design documentation and models. We redesign the internal structure to work with our TrueCore framing while adhering to our proposed connection methods. This redesign is reviewed by LD Consulting, in which they will talk to shortly. Once the project team have approved our drawings and the frames are put directly into manufacture and started arriving on site within days. By 3D modelling the entire project, we can send the finished shape to the cladding contractors to detail and their prefabricated panels, whilst the connections are being approved by our stakeholders. This allows the cladding panels and the TrueCore framing to arrive together on site for installation, thus speeding up the installation by removing the time-consuming step of traditionally site measuring cladding panels. You can visit TrueCore's website to download a case study on this project. The next two level crossing removal projects we were involved in were Lilydale and Mooroolbark, both to be built concurrently with narrow construction programs. TrueCore steel framing was approved by the same construction consortium due to the previously approved design life supporting documentation, which meant we were able to make an immediate start in the design. The challenge with these stations was that we could not attach any structural connection to the concrete overpass. Using the design flexibility of TrueCore steel and its spanning ability, we were able to design a more intricate architectural shape that could be mounted to an already installed structural beam for the majority of the works. Again, being able to fully 3D model our framing in the overall project model allowed for us to install concurrently in multiple areas with multiple crews to achieve completion in time. CMG frames were also able to provide modelling to the cladding and lighting contractors to ensure once the framing was in place, all relating elements were able to be installed straight away without having any site measurements take place. The images here from Mooroolbark Station show the complexity of the modular design required to avoid clashes with the existing structure and architectural elements. Again, we designed the TrueCore frames to be delivered to site in complete modules that could be installed without the need for cranes or lifting equipment. The inherent strength of TrueCore steel was designed into the shapes, making them lightweight, easy to handle while maintaining their shape, meaning you get what is coordinated in the model space arriving on site millimetre perfect. The challenge on this project was designing a bracketed connection to the structural beams without penetrating the beam itself. The main option that was put forward was a connection from Europe, which would take 36 weeks to arrive, which was not acceptable for the construction program. In conjunction with LD Consulting, we came up with a design using only off-the-shelf components, meaning we could manufacture in-house and get the brackets to site in a suitable time. TrueCore high tensile strength allows us to create strong cantilevered modules to support the CFC cladding, allowing limited connection design to work and keep the project on time. Here you can see a section drawing of Lilydale Station, so you can see the connection points and details. Felix from LD Consulting will talk more to this in his part of the presentation. You can see the minimal areas we had for framing structure and the limited connections. Bell Station is a fantastic example of an architectural element that had not been documented, even though construction had already commenced. The cladding contractor brought this challenge to CMG frames, and we were able to 3D model the shapes and design the framework necessary to support the unusual shaped window shrouds while maintaining the structural integrity. The challenge was to support the heavy windows whilst connecting to an outer structural steel beam, while providing the cladding frame support, which you can see are asymmetrical shapes and angles that only 3D modelling and flexible design using TrueCore steel frames could achieve. The benefits for the project stakeholders was architectural accuracy for the frames that were delivered, and they were installed in a planned sequence that supported the frames when installed from the ground up. The accuracy of the CMG frames process and design meant the windows sourced from overseas by the client could arrive to site at the same time with the confidence fitting in place perfectly. The final images of Bell Station were pretty impressive, still a real standout on the project. Here's some more completed photos showing that the architectural design increasing from station to station. Felix from LD Consulting will now talk to some of the challenges through these projects.
Yeah, thanks to Luke. Gave a good introduction on all the railway projects that we've worked on. So I'll speak a bit more on the engineering side of things, particularly the engineering challenges we face and the considerations during the design process. So obviously, I'll give two examples. The first one is Mooroolbark Station. Obviously, we are dealing with a really complicated geometry, and we are very restricted in terms of the substrate that we can attach our frames onto. So we're not allowed to fix to all the pre-tensioned concrete beams due to the issue that it may compromise. So the only options we left is to fix onto the existing structural steel. But again, Luke mentioned earlier, due to the short amount of coordination and due to the quick turnaround in the design time, so we cannot prefabricate a lot of the fixing on the structural steel or even pre-drill a lot of holes. And the other problem we face is a lot of the framings need to accommodate some mechanical and an electrical conduit. So as you can see here in an example of the shape of the framing that we have to deal with, and in particularly in areas that we cannot put brace, so structurally is a bit unstable. So the solution we actually come up with is we're utilizing all the blocking frames in between the adjacent frames to act as a web plate, like a stiffener plate, to enable a moment connection to achieve between the different LGS members. And obviously, from a design point of view, we also came up with a clamping system to clamp onto the existing structural steel I-beam and using a tension friction bolt. So we actually just applies the required wind and seismic forces onto the framing and extrapolate the reactions at the fixings and design appropriate to ensure that there is appropriate frictional resistance to resist the required loading. The second example I want to have a quick presentation on is the Bell Station facade. Obviously, this one we're also dealing with complex geometry, and all our frames are actually cantilevered beyond the substrate, which is structural steel framing for this job. And we also have to support the weight of the window on top of all the wind and seismic action. So again, we identify the critical case in the framing and create a simplified design model for it, apply the required wind and seismic action as well as the self-weight of the window it supports, and design the appropriate, just design the fixings to support all the required loading to meet the current Australian standard. One other thing to note regarding the fixings of the light gauge steel is we have to particularly be cautious about the local stresses on the flange of the web where the screw is located, because we're dealing with a thin material, and sometimes local flange web buckling due to fixing reactions can be critical.
The Whitehorse Performing Arts Centre, working with our partners at Melbourne Masonry, the scope was to design and engineer facade framing to support brick face cladding. Further to this, as much of the brick cladding as possible was to be done off-site, and the architectural express joints were to be maintained, meaning the pre-clad modules would need to be 3.4 high by 12 metres long in some cases. If you're not familiar with brick face system, it's a 25mm brick on rail, replacing the need for traditional brickwork, whilst maintaining the appearance of traditional brickwork. The builder wanted to eliminate scaffolding around the building in order to allow the internal construction to continue. Face bricks were pre-installed off-site and craned into place, sequenced so that access to site was maintained to keep up with the program and allowing the inside finishing trades to continue work. CMG redesigned the facade frames and supporting steel brackets to allow for large format panels to be installed. This was coordinated in 3D software between ourselves, the structural detailers, to achieve the final result on site. TrueCore framing is the perfect combination for brick face cladding. With the traditional brick thickness reduced to 25mm, the framing fills the void left behind to the building structure, making the system structurally sound. The high tensile strength of TrueCore allowed us to produce these large panels and crane them into place, meaning all architectural design intent could be met. The pre-clad design for this facade saved months of time on site and eliminated the need for costly scaffold to the perimeter of the entire project. At CMG Frames, we have developed our own lightweight curve system specifically for facade work and strong enough to be used over large applications you see here. The ability for us to coordinate between all trades and the architects for the brick layout was all made possible through CMG Frames driving design in the 3D model space. BIM coordination has become a major part of how we are able to create such incredible facades. The end result is pretty spectacular, with seamless transition from brick face to traditional brick. All involved in this project deserve a huge thank you, particularly our friends at Melbourne Masonry. Felix from LD Consulting will now discuss their role at WPAC.
Yeah, again, thanks, Luke, to give a brief introduction on some of the brick-clad project that we've worked together. So I'll specifically talk about two jobs. First is the Whitehorse Performing Arts Centre. So some of the challenges we faced on this job. And also the second one is 480 Swans. I'll start with the Whitehorse Performing Arts Centre. So I guess the most difficult thing we face in this is that all the claddings are down on ground before they are lifted. So the cladding and the frames will then be lifted all together. This is to obviously to save construction costs and time. But we'll have to design the lifting procedure cautiously. In particularly for this job, we're dealing with a lot of curved facade sections. So for the straight panels, the lifting procedures are quite straightforward. We've designed LGS framing utilizing the truss action, design the panels to span between the lifting point, and obviously in terms of the actual lifting point itself, we also need to look into the local stresses induced by the lifting action on the light gauge steel sections, and apply a gusset plate to disperse the loads. I guess the most challenging bit is with the curved panels. So with the curved panels, it is structurally impossible for us to provide bracing members, as it will interfere with the radius of curvature of the panel. So the solution we came up with is to adopt a flat plate noggings front and back, and also utilize metal strap bracing to make the whole thing a stiff and rigid diaphragm to do the lifting. As you can see on the screen, the layout for the curved panel is shown here.
The next brick project at 480 Swan Street presented its own set of unique challenges. This time the building was to be entirely scaffolded due to the limited space along the facade. The building had also already been made completely watertight, meaning our fixing points were minimised to slab faces only. Combined with a heavy pocketed PT slab and a curtain wall protruding up to 80mm past the slab meant that we had to come up with some new bracket designs quickly, as these issues were only discovered once we had access to site. We worked closely with LD Consulting to come up with heavy-duty bracketry that would cantilever up to 80mm off the slab, while also having the strengths to support the brick face cladding and framing over large spans to avoid PT pockets. Felix will talk about these challenges shortly. TrueCore allowed us to build the strength to meet those spans and take the weight of the brick face. while keeping the framing light enough to be manually handled through scaffold. The unique shapes were another major challenge on 480 Swan Street. We had to maintain the fixing spacings needed for the brick face system, along with complete support to each column and spandrel interaction. Again, all of this would not be possible without 3D modelling, planning and building in tolerance to our connections from years of experience in facade manufacture. The end results were again pretty spectacular. Working with our partners at Casello, it's always a pleasure to bring these facade designs to life. Felix from LD Consulting will now discuss some of the challenges we overcame at 480 Swan Street.
Yeah, the second example I'm going to give is 480 Swan Street. This one is actually the cladding is done after the frames have been installed. However, this one also have its own unique challenges. So first of all the frames will need to be offset from the slab edges. Also, we're dealing with an uneven slab edge profile. That means the installer on site will need to do minor adjustment in the horizontal direction on all the frame. And the third one is obviously we'll have to design to accommodate for slab movement and settlement. So the solution we came up with is to introduce a thick angled bracket, steel bracket, to support the light gauge steel frame. However, this introduced another problem for us is it further increased the overturning of the frame as well as the future cladding due to this self-weight. So we have to design all the bracket for a significant overturning moment. And secondly, as you can see, we have allowed for horizontal slotted holes on the fixing bracket. This is to accommodate the minor adjustment the installer require to install the frame. However, if horizontal slotted holes are installed, then we cannot, introduce vertical slotted holes on the same bracket to accommodate for slab movement and settlement. So the solution we came up with is utilizing the nature of the light gauge steel by adding in those 1 millimeter thick plated bracket. So in another word, we introduce the movement joint on the lightweight frame itself rather than on the fixing bracket as opposed to a more traditional approach. So with this thin plated bracket, we introduce a slotted hole at the top, and the bottom obviously will just be directly screw fixed onto the frame at the lower level. And we intentionally leave a 20 millimeter gap to allow for slab movement in between the lower and the upper frame. With the large brick piers on the facade, we actually verified all the reactions on hand, but also done a three-dimensional analysis and by modeling everything in an analytical software, and obviously applies the required wind and seismic loading on top of the self-weight, and design the fixings and also analyze the frame for strength and serviceability.
New Street Brighton is part of the public housing renewal project and consisted of 4 individual buildings. Our scope was to design a facade system that could be pre-clad off-site, driven by the lack of space around each building. As part of the public housing renewal project, the buildings needed to be airtight. C&G frames worked closely with Casello to design a system and sequence that meant this could be achieved from inside the building. CMG designed its own deflection head and worked with LD Consulting to provide full airtight facade solution that made this possible. The truss design, incorporating the extension of the facade, eliminated the need for concrete past the fourth floor, saving the client a huge amount of money. The truss were designed not only to support the facade, but to minimise the steel and install time while leaving cavity for the service access throughout the entire roof space. The TrueCore frames were designed to fit in loading bays and the sizes capped to ensure they could be manually moved around the floors without the need for expensive equipment. It also meant less labour was required to install each faced framing, freeing up manpower to work across multiple buildings concurrently. Due to the speed of prefabricated installation, the builder was also able to close up the building quicker and get the internal trades underway sooner.
Thanks to Luke to give us a good introduction on some of the other facade projects we've worked on. So I want to speak more specifically about this job, which is New Street Brighton. It's a public housing renewal project. So what we've provided in this design is the facade framing and also the roof trusses structure. So in terms of the roof trusses, we have adopted a design approach to minimize the amount of steel used. So instead of a more traditional trusses you build on top of the structural slab, we've actually designed it as another floor level using load-bearing walls and shallow roof trusses. However, this means that we also introduce a new challenge, is those big gable ends, it'll need to be designed like a facade wall. And in a more traditional approach that we actually required to introduce a lot of heavy gauge steel wall header members spanning in between the structural steel post to restrain the facade framing at the gable ends. But in this instance, we've actually utilized a bracing configuration on the roof to eliminate all the structural steel that's required around the perimeter of the roof. We have provided bridging members, light gauge steel members, to tie the first 2 to 3 adjacent roof trusses together and locally introduce additional metal strap bracing so that the top chord of the trusses, of the adjacent trusses around the perimeter, can act as a deep wall header truss and eliminate the requirement of the structural steel wall headers in this instance, like in a more of a traditional facade design.
Xavier College Q Campus upgrade scope was originally a simple externally fixed facade and roofing structure. The project was to be coordinated with a BIM manager for all oncoming trades so that the CLT could be ordered months in advance from Italy. During the process of coordination through the online BIM software, we were able to eliminate all the structural steel support for the windows and the large vertical feature fins, saving the builder thousands of dollars in an early stage of the project, which, as you can imagine, made them extremely happy. The TrueCore facade was modelled over the CLT, meaning that as soon as the CLT was erected and in place, the facade could follow, closing up the building, eliminating time of measuring on site. This transferred through to the window contractors and the architectural fins, accelerating the entire facade component of the build. TrueCore steel allowed us to achieve the spans and strength to support the oncoming trades you can see in these pictures.
As Luke previously mentioned, we're able to eliminate a lot of the structural steel that's been documented on Xavier College with a light gauge, with all the lightweight facade system. So for this job, we actually have to design all the facade to support a very large windows. In a more traditional approach, you will have a structural hollow section mullions with like a PFC header or a steel member to support the window frame. But in this instance, we've designed all the light gauge as a double cantilevered sections, utilizing the depth of the CLT floor and glue lamp beams to design the light gauge steel as a series of stub columns, if you want to call it, to cantilever above and below the timber structural slab and beams to effectively eliminate all the required structural steel, header, and seal members in this instance. And obviously, it saves a lot of cost for the client and saves a lot of installation time as well.
The project at Cannon's House scope was to provide a full newly designed structure to an existing building without any demolition. The process of as-built mapping and 3D modelling allowed us to achieve a facade design completely integrated into the current structure. Installed off a mast climber, CMG frames had to design these components small and lightweight while maintaining strength to span and support the Rimax cladding. All of this made only possible by using the TrueCore product. The lower parts raking away from the building were made up of lightweight truss frames to accurately meet the soffit lining, with an overlaid panel system for the cladding and installer to directly fix to. This eliminated the need for secondary top hat installation, saving a huge amount of time on site. Exposed aggregate render meant fixing method was important, working closely with LD Consulting. As you can see, it was a fitting upgrade and finished to an architectural hub. At Quest Apartments in Geelong, CMG Frames designed and integrated facade feature boxes and balustrade framing together, supporting multiple facade finishes, CFC, aluminium, and Hebel. The flexibility of TrueCore framing allows us to design smaller, lighter, and more accurate framing to deal with different cladding types and thicknesses across multiple of integrated areas. The support brackets had to be designed to be completely hidden behind the white boxes you see here, while allowing the boxes to sit off the building. The features are fully wrapped on all four sides with aluminium cladding. We worked closely with LD Consulting to develop a bracket that was strong enough but also practical to be installed quickly and easily. At Quest Apartments, we have 300 by 300 boxes spanning from balustrade to balustrade, from floor to floor, and across large span openings. all fabricated millimetre perfect to avoid any following trades needing to straighten the frame and complete their works. Previously designed as hot rolled ladder framing, a massive cost saving and ease of installation was achieved by changing to true core framing on this project.
As Luke have previously mentioned, this Quest Apartment Geelong job is a good example of a lightweight providing a architectural features on the external facade. So in this instance, we are providing all the fins that require to be hanging off the structural slab edges. So I have to say one thing that luggage steel is not really good at is to provide a moment connection, cantilevering out from the structural slab. In particularly in this case, that all the frames will need to be offsetted to enable an exterior facade to be installed. So the design approach we've adopted is we provided a series of structural steel hollow section outriggers at each slab level, and simply just design all the lightweight framings to span in between the structural steel outriggers. And obviously, again, the fixings from the structural steel framing to the light gauge framing will be done with screws, and it's quite easy to install on site.
That's the end of our presentation. I'd like to thank the team at BlueScope Steel for arranging this opportunity for CMG Frames to present to Engineers Australia Group. Hopefully today you got an insight into how we approach facade design, and by using real-life examples, the flexibility and benefits of using lightweight true core steel. Thank you.
Hi, thank you. Thank you to our great speakers this afternoon. It's now your turn to get involved, and please ask our speakers questions via the YouTube chat box and who your question is directed to. Thank you to everyone who submitted questions whilst registering. I'd now like to welcome Michelle Giselle, National Business Development Leader, Commercial Framing from Australian Markets from BlueScope Steel. Michelle works for BlueScope Steel in a role that promotes the adoption of the LGS framing made from true core steel in emerging applications within the commercial sector. Michelle will be joining the Q&A to address any questions specific to true core steel. So I might kick off with you, Felix, and we've got a question that came in from Paul, and Paul's watching from Victoria. Good afternoon to you. Asking you, Felix, how are connections to concrete handled? Also, what are the typical deflection criteria for facades? Felix.
Can you hear me okay? Yeah. Sorry, it's a bit of a technical problem here.
Oh, okay. Well, we might just move to Luke to give you a bit of time. Luke, I've got a question for you that's come in from It's also watching from Victoria, asking you, would connection to the light gauge steel framing be suitable for rope access, swing stage purposes, i.e. lateral restraints and diversion anchors? Luke.
Sorry, Amanda, can you repeat that? I just had a bit of an overlap.
Yeah, we had a question that came in from Robert in Victoria. Yep. And Robert's asking you, Luke and Felix, would connection to the light gauge steel framing be suitable for rope access / swing stage purposes, i.e. lateral restraints and diversion anchors? Thanks, Luke.
Yeah, so we deal with that a fair bit. In a lot of our lightweight designs, particularly our top structures, like our top level structures, not so much directly connected to the facades, and I'd also suggest a swing stage probably way too heavy loads. But rope access in particular is a pretty common fixing to a lot of the commercial projects we do. So they're normally fixed through the roof sheeting, and we just increase the loads through our calculations onto the trusses, onto our lightweight trusses. And that can be solved pretty easily. There's no real major upgrades that we need to do to the steel. It's strong enough to take a lot of those access loads.
Thank you, Luke. Felix, are you back on? I might just stick with you, Luke. We've had a question that's come in from Zabi, who is actually watching from overseas. Good afternoon. Asking you, Luke, what steel is used for light gauge steel framing? Thanks, Luke.
So predominantly TrueCore product, but the steel thickness itself is 1 mil, so we stick with that. Mainly because just to keep the weight down, you can go a bit heavier, but 1 mil is really good for, you would have seen some of our projects where we try and keep away from as much of the mechanical lifting as possible. So we predominantly use 1 mil BMT, which will give us a lot of spanning strength, while also maintaining that lightweight, ease of install for our clients.
Thank you for that, Luke. We've had a question that's coming from Han in South Australia, and it's to both Felix and Luke. So, Felix, if you are able to get the technical difficulties sorted out, if not, Luke, to pick it up. So Han is asking us, what is the software used during the design?
Well, obviously we use various design software. So a lot of the documentation of light gauge steel is done in Facade, which allows for drafting as well as capability for performing design and analysis of the steel stud members. And for some out of ordinary design, we typically use space gas to do the modeling.
Thank you, Felix. And just staying with you, Felix, for now, we've had a question from Cool, who's asking, also watching from overseas, Felix, and then maybe Luke, you may want to comment. It's very topical, asking how much fire resistance requirement in steel frames are there for facade purposes? Felix, kicking off with you.
Well, the fire resistance requirements also is more up to a specific design. But normally we don't design the the light gauge steel frame themselves to be resisting any fire. The fire resisting element is more for the cladding that is attached onto our framing. So they just act as a fire protective layer for the steel framing. And Luke, would you like to just add a bit more?
Yeah, I guess when we start designing a facade, we work pretty heavily with the fire engineers on the project. So there'll be a lot of ways that the fire and smoke is dealt with in the facade and the building itself. So that if that turns to the internal shaft liner, a line that exists to the outside of the building, so the facade is actually separated. So the lightweight facade we build will be to the outside, say from the slab line, which means then that we'll have smoke breaks sort of at each level, which is where we design for the deflection and stuff as well. So all sort of works in together.
Thanks, Luke. Thank you for that. And Michelle, bringing you into this afternoon's discussion, we've had a question asking, what is the advantage of using TrueCore steel in a light gauge steel framing design? Thanks, Michelle, and welcome.
Thank you, Amanda. So I think Luke and Felix have really showcased how light gauge steel framing can be used in a number of different applications. I think TrueCore has some extra advantages as a material going into light gauge steel framing. It has additional technology that we use in the manufacture of the steel called Activate, and that Activate technology means there's extra corrosion performance of the actual steel. The other advantage is BlueScope is an Australian manufacturer with a lot of local support. So there's people on the ground that if there's any technical issues that either the fabricator or builder requires, then we're available to support. And the other advantage of using TrueCore steel is BlueScope has done a lot of work over time to resolve some of the sustainability pathways required now by the market. And as a result, we have EPDs that can contribute to the achievement of Green Star ratings on projects, as well as BlueScope is certified to a responsible steel standard, which equally means that it can contribute to the attainment of Green Star rating. Luke hinted at this before, but TrueCore steel is available in a number of different grades, from G450 to 500 to 550, and different thicknesses as well. So there's a bit of flexibility on what products you can use that are most appropriate for the design. Thanks, Amanda.
Thank you, Michelle. Thank you. We've had a great question that's come in from Vincent, watching in New South Wales. We've seen some amazing projects that you showcased in today's webinar. So starting with you, Luke, Vincent's asking, what was your favourite project? And maybe I'll throw in why.
Yeah, there's definitely been a couple of them, but I'd suggest probably the Whitehorse Performing Arts Centre, that brick job that we did with the guys at Melbourne Masonry. Just the way it started off with the design, working in with the steel fabricators and the structural guys. So all the BIM modelling, and bringing all that together, and then to see that come to life in giant 12-metre long curved panels, getting craned in and the bricks all coming together. I think that was probably, and the end result, I drive past, I live out near there, which is good, so I get to go past it a fair bit, and it's a pretty amazing project to see finished off, I would suggest. Yeah.
Thanks, Luke. Felix, your favourite project and why?
Well, this is a bit of a hard question because every project has its own unique challenges and difficulties. So it's really hard for me to pick one that to be considered as my favorite one. I would say that all the projects we've shown today, there are certain elements that I'm really enjoying working on, and also at the same time, it's causing me a lot of headache at the same time. So, so I'm overall, all I can say is I've enjoyed them all overall. Yeah.
Thank you. That was a good answer. Thanks very much. Michelle, coming back to you, we've had a question that's coming in asking, what about other applications and is it beneficial to use LGS framing? I think that means what other applications is it beneficial to use LGS frame?
Yeah, absolutely. So I think you've seen showcase today the design versatility of using light gauge steel framing made from TrueCore. We've seen curves really showcased. We've seen diverse spans that it can straddle across. We've also seen where accuracy is required, that it is really able to be designed to pinpoint accuracy, allowing for the design and the construction timeframes to be tightened. And where it's required within a project that there is a strong to weight ratio required. So it's very lightweight relatively to its strength. And that has provided benefits where you want to minimise the amount of either equipment on site or the amount of manhandling required. So it really lends itself to those sort of applications. In terms of applications itself, the sky's the limit. Like we see light gauge steel framing quite commonplace now in traditional wall and roof truss designs. But as we've seen today, facades and balconies are emerging. We're also seeing retail fit outs and quite significant retail fit outs in a structural sense come through. More recently, we've seen top story build. So it might be a large project that's 6 or 7 floors high, and the top floor or floors have been converted to light gauge steel, mainly to save costs on the preliminaries or with scaffold and to speed up the construction in those last stages of the project. And I'm also seeing now a fair bit of use of light gauge in modular. So the sky's the limit as far as light gauge steel framing use made from TrueCore steel.
Thank you, Michelle. Great answer. Alex has sent in a couple of questions both to Felix, but the first one, Felix, I'll split these two questions up. The first one, Alex says, hi Felix, what software do you typically use for the design? It looks like the analysis is in Space Gas.
Well, that's spot on. It is Space Gas, as I mentioned in, I think, one of the other questions. So yeah, it's a pretty versatile analytical software, and it's very readily available in here. Yeah.
Okay. And staying with you, Felix, and then actually might also ask Luke to answer this one as well. Alex is asking you, Felix, have you any tips you could give engineers about where to start if you're looking to design in light gauge steel framing? Thanks, Alex.
Yes, so I think the biggest difference in terms of a light gauge analysis and modeling is every connection between individual LGS members is essentially a pin connection, in opposed to a lot of the structural steel, which you can achieve a moment connection through adjacent members. So in terms of modeling and analysis, you need to be extra cautious about your restraint, your member fixicity, and you have to basically assign a fixicity property to allow for pin connection between individual frame members. And the other thing you need to be a bit cautious about is obviously dealing in terms of designing fixings and connections, be a bit cautious about the local stresses that can induced by the loading. Yeah.
Thank you, Felix. Luke, do you want to add to that?
I guess, yeah. There's probably not a lot I can, I guess, talk to on that sort of front. I think Felix sort of captured it all with what he's saying there. Yeah.
That's great, thank you. Questions coming from Ahmad, Felix, asking you, what are the specified allowable deflection? What is the specified allowable deflection, particularly for the purpose of cladding? Felix.
Well, obviously, the serviceability requirements all depends on what sort of a cladding material we adopted. So unless there is a more specific requirement from the cladding supplier or the manufacturer, we typically adopted a 1 to the 240 for a normal type of cladding, and deflection on 360 for a brittle cladding system, which is pretty typical in practice in the industry.
Thanks, Felix. Thank you for that. A question for you, Luke, that's coming asking, my question is a general one. In order of difficulty, what are the major challenges in retrofitting steel frame facades? Luke.
I guess probably the main first challenge is just working with the connections we have available, spans and shapes, that whole, everything tied in together there about how we're actually going to build that structure. So coming up with that plan and working with LD Consulting to make sure it's possible to be able to be done. That's probably the first challenge. Second would be, in order of difficulty, is really getting those connections dialed in and making sure they're also practical as well as structurally sound. There's no point us designing a huge, expensive bracket connection off a slab if it's going to be impossible to install and blow the budget out what we've designed. So I guess those two would be the main factors, the main challenges in retrofitting the lightweight facades that we deal with every day. I mean, you can go on to transport and how we're going to transport large size panels and stuff like that we deal with every day. But I'd suggest that those two would be where we start off and the first hurdles we get over in order to design a facade.
Thanks, Luke. Thank you for that. And just staying with you for now, Luke, we've had a question that's come in from Dean. Good afternoon to you, Dean, asking Luke, what is the standard gauge of steel used?
So we use predominantly for our facades is 1 mil. It's the G550 True Core. That gives us that high tensile strength, allows for flexibility in our connections. I talked about those connections before, just on how important they are because we don't always get a lot of access to a lot of fixing points. And that 1 mil G550 True Core allows us to, and you see the way we've designed a lot of our ladder framing with the lightweight, really gives us a lot of flexibility in our connections. Allows us that if we can't, we've got Rio pockets, we've got all different types of stuff that we can't use, or that blocks off our access for fixings. So it's a great product, and the 1 mil really it covers everything. So it gives us that strength and flexibility, but also not too heavy. You start getting up to 1.5 gauge, and you really start to increase the ability for the installers to put it in without needing massive lifting equipment.
Thank you. Thanks for that, Luke. And Felix, back to you. We've had a question that's come in from Isan, asking you, Felix, what kind of fasteners do you use to connect the frames to concrete? Normal dyno bolts, Kemst anchors, or screw bolts, or any specific product? Felix. Are you okay, Felix?
Sorry. Got a bit of a technical difficulty back there. So basically, we specify all sorts of post-affixed anchor system into concrete. We've used like a mechanical expansion anchor, also screw-in anchors, as well as chemical anchor. It all depends on the loading cases and the reactions we get from the fixings. Or even in some of the railway project we've worked on, there are specific requirement on the design life of the anchor fixings that we have to design for 100 years of design life. So in such case, we've only allowed to use post-installed anchor system that's been approved for 100 years of design life.
Thank you, Felix. Thank you for that. Luke, Dean is asking you a question. Is there a different gauge for modular due to the fact that they are transportable? Luke?
No, like I was saying before, the 1 mil we tend to stick to for all of our facade work. When it comes to transportation and stuff like that, it's how we design. I think I was talking about that before as well, saying it's one of the main challenges we come up with based on the size and scale you need to create while being able to get them transported to sites. Number one challenge, I think, in prefabrication. But it's always the same. We always use the same material. We just design differently on how those modules are going to go together, and how they, plan for how that's going to be transported and what work's going to be done on site to assemble those modules before they go in, and just really that sequencing is what we plan for.
Thanks, Luke. Michelle, a question for you that's coming from Josie and asking you, where is true cost steel most widely used at the moment? Michelle.
Thank you. So true cost steel is widely used right across Australia. So we supply to all states. It emerged originally in residential applications, so class 1, and it has significantly expanded from that into all sorts of commercial applications now. We see it a lot in childcare centres, education, hospitals, standalone retail. So it's really quite diverse where you see it and where it can be used. It's really now just about engineers getting familiar with its best use and understanding how it gets calculated with other structural steel and other alternative structural components in order to get the best outcome for their clients.
Thanks, Michelle. Felix, a question for you. Have you considered seismic loads for the cladding and the cladding support? Felix.
Yeah, so obviously seismic design is part of the design requirement. So we assess all the seismic load in accordance with the current Australian standard AS 1170.4. And obviously in most of the design cases, seismic is not the governing load, and wind load is a more critical design case. So yes, so the short answer is we have to consider seismic design, but in most of the design cases that wind is the more critical and more governing design load criteria.
Thank you for that, Felix. We've covered a lot this afternoon. We've talked about facade design with light gauge steel frames, and we've had some amazing case studies that we've looked at. For our audience, starting with you, Michelle, I know you didn't actually present, but what would you like to leave, just a couple or a few key takeouts, what you'd like to leave with our audience this afternoon? Michelle.
The key takeout I'd leave with the audience is keeping their mind open to the use of light gauge steel. As we've seen in the case studies, there's opportunities to save time in programs and certainly costs in removing some of the ancillary costs involved with the project. Engaging with the professionals like Luke and Felix early in the process when a project comes about is really recommended to optimise the opportunity to replace structural steel or other elements with a true core steel frame. So really just encouraging people to embrace it and see what it can do for their specific projects.
Thanks, Michelle. Felix, your key takeouts.
Why?
From your presentation, but we actually have all.
Obviously,
That's okay.
LGS, the design can be quite challenging, and especially you're dealing with a lot of the thin material. So there will be a lot of things to consider in the design, and need to be a bit more cautious about, but in particularly the local stress of the light gauge sections, and but overall, I think it's a good material to be adopted in the construction field, and I certainly recommend encouraging more engineers to look into the LGS design.
Thank you. Great takeouts. Luke, just before we go to your key takeouts, because we have had a question come through on the standards, asking you what ASNS standard do you follow, particularly for fabricating and installing?
I think that's probably more of a question for Felix on the standards of things. I don't tend to follow or have that information quite at hand. I'm afraid he's more of the standards man than I am.
Felix, the standards man.
Well, in terms of the design, I think 4600 is the standard to go. I mean, AS 4600. And there are also a number of other standards which I can't remember on top of my head the exact number on fixing screws, and also like fabrication wise, yes. So can't really
Too much.
remember on top of my head
That's okay. We're putting everybody on the spot today, that's for sure.
Yeah, that's a tough one to remember. Yeah.
So, Luke, as you say, you covered a lot in your presentation. What are the key takeouts you'd like to leave our audience with this afternoon?
I think it's pretty similar to like what Michelle was saying. It's just people being able to open their eyes and see what you can do with lightweight steel. We spend a lot of time talking to builders and our clients and just trying to get them to see what's possible and what you can do. A lot of the challenging shapes and designs and things that people are still working with on structural steel, when obviously, in my opinion, there's a much better way out there. It can be cheaper, it can be more cost effective, not just the material itself, but the on-flow cost for labour in particular, which is a massive problem on sites. Just hopefully today has really opened people's eyes to what you can do and what you can achieve shape-wise. That we're seeing more and more complex shapes in design, architectural features, and lightweight steel, and particularly true core, really lends itself. Just in that space, it's perfect for it. It's a perfect situation. It's a perfect solution for a lot of those situations where you've got cladding. Just the lines there are so much more exact than if you're working with traditional hot rolled steel, where the guys are straightening it afterwards and stuff like that. So again, like I say, the cost saving you can get from it is really impressive. And once we've worked with a few clients and they've done it once or twice, you find that we work with them repeatedly. Just once they understand it and can go through a project and go through the sequence with us, you'll find that there's no looking back.
Thank you. Thank you to all our speakers today. And it is all the time we have left today. So please join me once again in thanking Luke Cockrell, Felix Dong and Michelle Giselle for their time and input. I'd also like to thank Engineers Australia's long-standing industry partner, BlueScope, for their support. I'm also delighted to announce Engineers Australia's 2024 Climate Smart Engineering Conference early bird registration has just been opened. Please follow the QR code on your screen for more information. As always, we're looking for your feedback, what we can do better, topics that you're interested in. So if you could please complete a 2-minute short feedback form, which is linked in the description box below. Thank you again for joining us, and I look forward to seeing you again at our next Thought Leaders event. Thank you and good afternoon.